Okay. So what this webinar is all about today is how to get the end user perspective on your Wi-Fi network's availability and performance, and hosted by NetBees. You'll learn how NetBees flips the script and lets you see what the end users are experiencing, which is our specialty. Here is the agenda today. It's going to be about a 20-minute webinar followed by the Q&A. We'll give an overview of Wi-Fi monitoring, some Wi-Fi monitoring challenges, our agents, which are Wi-Fi sensors and their endpoints, some testing capabilities, Wi-Fi metrics and tools, and then sensor deployment, followed by the Q&A. And as you've probably seen here, we have me and Panos, who is going to take it over from here. He's from our engineering department and also our COO. So thanks for being here, Pano.
Thank you, Jess. And let's get started. So why are we here today, right? Each one of us has to deal to certain capacity with Wi-Fi, either as a designer or as person of the deployment team, or managing and troubleshooting Wi-Fi, or all of the above, right? And even if when we have the best designed Wi-Fi, and every Wi-Fi installation should be designed properly, and before going to deployment, we all know that at the end of the day we're going to have issues, right? Wi-Fi is its own beast in terms of performance, behavior, and we often, of course, care about what the end users experience, regardless of how they're getting their connectivity through Wi-Fi or ISP. So we want to be able to understand when a user opens a ticket and complains, and of course, they're going to blame first the Wi-Fi or the network. Where is the problem really coming from? Is it their laptop, the Wi-Fi, is the ISP, the backhaul, right? So the very least, we want to validate if Wi-Fi connectivity is there, and be able to understand this from many remote sites. Of course, if we're managing a network, as typically our customers do, that have many remote branches, can be campuses from university, it can be bank branches, clinics. We want to make sure that at each one of these locations, Wi-Fi is up and running. Of course, there are many ways to do that, also from the controller standpoint of view and tools that each vendor offers. But in our case, we cover an aspect of the Wi-Fi experience that vendors cannot cover from, when they give information from the access point perspective. That's the end user experience, right? What exactly the users see, not from the access point perspective. So we're going to measure what's the upload, download speed as a basic measure of Wi-Fi experience, or network experience, and validate signal coverage. And at the end of the day, have an assurance that Wi-Fi is up and running, and if there's something wrong, can get notified and have historical information to be able to troubleshoot effectively and quickly without having to deal with calling users, trying to be on the phone with them to troubleshoot, or even do a track road, send somebody there to do a packet capture, etc. Right? So let's see how we do that. In our case, in order to capture the remote end user experience, we use sensors, or agents, as we call them. And the agents can be hardware devices, as many of you know, or they can also be software sensors that run on the user's laptop. And these sensors can capture the user experience. At the end of the day, they're another client in your network. They connect to your Wi-Fi network through, whatever authentication method you use, EAP, Open, PSK, and they tell you from its now side that you have a sensor deployed at. They tell you what does the sensor see, right? And what it sees can be related to the RF layer, signal strength, link quality, can go up to the network layer, measuring latency, capturing routing, and also moving up to the application layer by capturing HTTP, for example, response time, DNS resolution time, etc. So this is what the sensor looks like. So it's a hardware device again, the hardware sensor, small size, dimensions are 5 by 7 inches, and can be powered either by PoE or PSU. That means that the sensor can be plugged into your Ethernet if you have a drop somewhere, and it uses the Ethernet connection to communicate with the server and the dashboard, but also has the ability, even though it's a wireless sensor, to run tests over the wired network. So although it's a dedicated wireless sensor now, and you run a number of synthetic testing over your wireless, let's say you run the same exactly latency test or bandwidth test with your wired network, you're able to compare very easily what is the performance and the delta between the Wi-Fi and the wired. Let's say now you have an issue and it's detected only on the Wi-Fi side, but your wired data and baseline looks at this, according to historical. Then you can isolate and say, okay, at this point in time, my Wi-Fi stopped performing as it used to be. My wired network is not affected. So you can isolate the problem and understand that's from the Wi-Fi side, right? But it can also act as a wireless only sensor. That means you can power it from the wall outlet. And in that case, it's gonna associate, doesn't give the Ethernet drop. It's gonna connect to the wireless network as, again, as another client, and use the wireless connectivity both for communicating with the dashboard, but also running all the synthetic testing. Of course, the benefit of having an Ethernet drop on the agent is that even if the Wi-Fi is not performing as well, you have the more reliable wired connection to talk to the server and know what's going on. Otherwise, if the Wi-Fi is down, you're going to lose the agent completely, right? Another now type of agent we have, and we released in 2020, I would say in the first year of the pandemic, was the Windows, Macintosh general software agent, can also run on iGel or Linux, but Windows and Mac are the most common use cases there, where the agent runs on the actually user's device. So in that case, you cannot go any more granular than that. And you can capture information that can really see what the user experience really are on a per user basis in terms of, like, again, Wi-Fi, signal strength, end-to-end synthetic testing to measure performance, right, and experience. So these are the two main types of agents we have, and the software agent, of course, can follow the user wherever they are. So now in this hybrid work-life balance, I would say, now if the user goes back home or they go to a cafe to work for a day and they have issues, you can really see what they really experience, right? And you can troubleshoot, help them as much as possible compared to waiting for them to come back in the office or being on the phone with them to troubleshoot and detect what issues they're facing. So now, how do we do this testing? The synthetic testing specifically, we talked about, a little bit that earlier, but in detail here, we have two categories of tests. One is what we call real-time tests, which namely are ping DNS, HTTP, traceroute, and path analysis. Path analysis is a more detailed traceroute, I would say, based out on steroids, as we call it. And we call these real-time tests because they run on an interval. So you can set, for example, like I want to have a 5-second ping test or a 2-minute HTTP test. You start the test, then it keeps running until you stop it or until you delete the test. Then the scheduled tests have the ability to run on a schedule during the day. Of course, you can also say I want to run this test on an hyperf test or a network speed test on an hourly basis, but the most typical use case that where you want to say, for example, I want to run a speed test, let's say, from a hardware sensor a couple of times overnight, just to get a baseline, of my kind of best possible performance when the network is clean and create a baseline. Then a couple of times, or during business hours, understand what's going on when actually users are in the network, right? So again, you put this on the schedule and they run continuously with historical information for each sensor. And similarly with iPerf, which many of you may know that is a type of bandwidth testing between two ends, like speed test, but speed test is more like with a server that is probably somewhere in the internet, right? But with iPerf, you can control both the source and the destination server. And VoIP finally is a scheduled type of test where captures run synthetic testing between VoIP testing between two agents and captures jitter, packet loss, and latency. And from there, it derives the MOS score. So for example, if, again, people have bad video conferencing quality, where is the problem coming from? Now, on the Wi-Fi metrics side of information we collect, more on the RF side, I would say, we collect information like signal strength, link quality, what, like SSID, its agent and user is associated to, what bitrate is established. And for this user, you can also do like a scan around your network or its sensor, understand what is the RF environment around them. That might be really useful, I would say, for remote users that are, let's say, in a dense city environment, an apartment building, and you can do a scan around their network and see, okay, this user is on this condensed network on that specific channel, and you can advise them, hey, those problems you were facing probably are going to go away if you change your router's channel. Even know how to do that. You hope they do. Or at the end of the day, you can tell them your Wi-Fi is really bad there, plug into your router, right? Because the best way to solve Wi-Fi problems is to get rid of the Wi-Fi. That's not actually uncommon for people. Right now, for example, I'm plugged in, right, to run this webinar. I want to make sure I have no hiccups, although my day-to-day work is done on Wi-Fi, right? So definitely replace Wi-Fi with wires when you can. The sensors now, the hardware sensors, have some more advanced capabilities. So with each sensor, you can monitor up to 4 SSIDs. So let's say you have a guest open SSID on your campus, you have your corporate SSID, and then you have maybe a third or a fourth one, and one for IoT or whatever, right? And so you have the ability to ask to set a hardware sensor to go in a round-robin fashion and connect on a specific interval on each SSID and run monitoring on each 3 or 4 of them. And for each one of them, can measure things like association, authentication, DHCP, so you can understand how long each step takes, and if there's a problem, connectivity problem, where it's coming from. This is also useful because you can test continuously your association, authentication, DHCP, if you run this continuous connection disconnection process, because we often know that once a user is connected and is associated, right, and it doesn't prom or change anything, then everything shows okay. But when a new user comes in and your Wi-Fi has issues, you won't know until you test that, right? So continuously connection disconnections, you're able to also monitor this if you have historical information about it. Finally, the last feature that is available only for hardware sensors is packet capturing. So this is done on an ad hoc base, I would say. This gives you the ability to set a sensor on a monitoring mode, as we call it. Of course, when you do that, the sensor not run any synthetic testing, right? So it cannot be both a client and a monitoring mode agent. So when it does that, you set it up to do a packet capture if you want a specific channel or multiple channels for a specific period of time, let's say 1 to 5 minutes. And so it does the capture remotely, and the pickup is downloaded on your machine to process further with any type of software like Wireshark, etc. Right? So of course, this is useful when you really go down to the packet capturing level to do some troubleshooting. How would you do that otherwise? Normally, you would have to deploy somebody, if it was a remote site specifically, with a laptop, right hardware, to do the packet capturing, right? And do that. Let's say you have an intermittent niche, you have to be able to do that quickly, otherwise you're gonna miss it, right? So now you have a sensor at the side. From the dashboard here, you can do the packet capture, get all the information here, and without having to do a track roll. And just to give a little bit of an overview of what you can achieve with this Wi-Fi monitoring and what is the complexity for different goals you might have. Of course, at the very basic level, you want to test that your Wi-Fi is up and running, right? And get some basic information about bandwidth performance, like download and upload metrics. So this is I would say, most basic thing. You would need one sensor, let's say, per site, just to understand that your Wi-Fi is up and get those metrics on the dashboard. Then you're going to go a little bit further and be a little more surgical with information like authentication, association, right? Also static testing to see how all the different let's say sites of a big campus are doing, and be able to be notified with granular information about any potential issues. You need to go on a more granular solution where you may require to have one sensor per few access points. And lastly, we're going to go even more detail and verify signal strength, link quality, and really have a more detailed view of your Wi-Fi performance. Usually we work together on a solution where we have a solution engineer work with our prospects to understand what their needs are, what are their constraints, and set up and go to an acceptable solution that meets their budget. Just an overview, a little bit of some specs of the hardware sensors. So again, it's a 5x7, I would say, hardware sensor that has gigabit interface, can be used for testing, can be powered both from the PSU or PoE, and then it supports Wi-Fi 5 currently, and we're working on the Wi-Fi 6 sensor as we speak. In terms of authentication methods we support, of course, all the basic ones, Open, WPA, EAP methods, and WPA3X that are coming with the Wi-Fi 6 that's going to be released in next quarter.